welcome back. Today we're going to continue our exploration of the new code contracts library that is coming out of the Microsoft R&D team. And this is something that will be shipped with Visual Studio 2010 and will be part of .NET 4.0. In this episode we're going to take a look at one of the best features I think is part of the contracts library, which is the concept of object invariance. The intent of the invariant condition is to ensure that a given instance of a class is always valid anytime its state is changed. Now, why would this be useful? Let's take an example of what we're going to look at today. In our little demo today, we have a time clock system set up. And we want to set it up so that anytime somebody clocks in or clocks out, that we ensure that they have not gone over or under the minimum amount of work that they're allowed to perform for that week. In our example, we're going to say you have to work at least 0 hours or more. The system can't set it up so that you work negative hours. And then you can't work more than 40 hours. That's a violation of our rules. Now, I could do this today, and I could do it pretty straightforward, but it's going to be a little more painful than it needs to be. Plus, I don't get static checking and all that good stuff that the contracts library is going to provide for me. So let's go ahead and take a real quick look at our code base. We have this class here called report card. A report card essentially will host daily cards. A daily card is the individual time clock for that given day. And when you can add a daily report card to the list, and all it does, as you can see, is it just adds a daily report card to the internal collection. We can also pull the total number of hours that all the loaded report cards have in them, so we can report on hours that they're over or under range. Now, prior to contracts, in order to ensure that we were always valid, I would have to do something like this. Say if total hours greater than 40, do something, right? And this works, but the problem with putting this kind of if checking in is that it doesn't give me the static analysis. It also means that anytime I want to add a method or remove a method or update a method, I have to ensure that I move that logic all over the place. Not really the ideal situation. So how can contracts help us, and how can the object invariant help us? Well, with the object invariant concept, what I can do is I can actually create a method that is part of my class. I can provide it an attribute, and every time the state of my object changes, I know that that invariant method or contract method will be called and will validate the state of my object. So let's go ahead and take a quick look at how we can do this. Now, the first thing you're going to do is you're going to want to create a void method. All methods that are invariant methods must be void. And we'll call this ensure report hours is in valid range. And we want to make sure we don't provide any parameters. And then in order to use the contract stuff, what we need to do is use the contract invariant method attribute. And that will tell the contracts library that this is indeed an object invariant method and should be used as such. Now, before we go any further, let's actually compile this and take a look at this via reflector, because I want to show you something. So this is done compiling. Let's bounce over to reflector. I've already got this up and running. Now let's go into my report card class. Let's disassemble this. If you're not familiar with Reflector, we have other Dimecast on that. I would highly recommend you check that out, because Reflector is a great tool that lets you peer into the guts of .NET. Now here's that object invariant call I have right here. Now you can see that it actually has the attribute attached to it, but it's not being used anywhere. Now the reason I wanted to point this out is simply creating this method and slapping the attribute on it doesn't mean it's actually going to be placed all over the place when the rewriting takes place. And in case you're not familiar, what happens with the contracts is there's a rewriter that goes in after compilation. Will actually weave code into your assembly post-compilation. Now, in order to get the weaver to actually work as desired, what we need to do is bounce back over to the code. So what we're going to want to do now is actually use a new keyword. So contract.invariant. And this is similar in syntax to the other methods on the contracts class, where it takes a condition statement rather than a few pieces of values. So let's just go ahead and add a few things in real quick. We're going to say that employee IDs must be greater than 0. This just ensures that no one provides a negative employee ID. We're going to grab a local pointer to total hours. And we want to do a contract that invariant total hours is greater than or equal to 0. And less than or equal to 40. So let's recompile this and see if the Weaver actually now put this method call in other places within our class. So if I refresh this, you'll see now every place that the state of my object changes, there's a call to this.ensure report hours is in valid range. This was new. This wasn't there last time we had this. And then you can also look that the code that we actually wrote in our contract invariant method is slightly different. The rewriter did some stuff on it, and that's fine. But you can see how adding this single method and allowing the rewriter to inject it in all the places needed can make life very easy for us and allow us to very easily and reliably extend our object in the future and know that the invariant check will take place. So how does it actually work? Let's take a quick look at that. Let me go ahead. I'm going to put a breakpoint right here, and I'll put one up here in the constructor. Now, if I bounce over to my test harness here, I have a very simple test that should actually pass all my invariant checks. So you can see I'm about to hit my breakpoint. I have not stepped into my invariant. Now, as soon as I change the value of my object, the invariant gets hit, and I start doing some checks. Now, one thing I want to point out to you, if I hover over this, it's still at 0. Now, what I want to point to you here in a minute is after I actually add a value to my collection, so let's make sure I have values in my collection. Oh, not yet. Here we go. So I'm about to add a value to my collection. And so you'll see that my employee ID is 1. Let's bounce over total hours. You'll see total hours is actually still 0. Now, that's interesting because I actually have a value in here. And I'm guessing if I come down here and call total hours, I have 9. This is an interesting little issue with the way the contracts handles and is rewriting the code behind the scenes. The first time I looked at this, it kind of stumped me for a few minutes, so I just want to point out that at runtime, the values that are inside this contract method might not appear to be what they really are. In this case, they're not really 0. It's actually 9, but it knows that and it checks it validly for you. So let's go ahead and continue over this. And it ran fine. I didn't get any exceptions, no dialogues, which tells me that I didn't violate any of my contracts. So let's go ahead and add this so that I can actually have my object invariant hit and violate something. I'm just going to paste in a few extra lines here. You don't want to see me typing that over and over again. I'm going to go ahead and remove this breakpoint. Now, this test should now throw an exception because I'm going to violate my range. I provided more report cards and exceeded my 40-hour maximum. And there you go. I have a dialog pop up telling me my invariant failed. My total hours needs to be less than or equal to 40. Let's go ahead and abort that real quick. So you can see that I can add this invariant method to my object. And anywhere within the object, if the state changes, the invariant gets called. Now, to me, this has some very positive upsides. So I can add a single point of check within my object to ensure that's always in the correct state. The downside here is whatever you do inside of this needs to be simple and light. Because this is going to get called every time the state of your object changes, you need to make sure that you're not doing things like connecting to a database or a file system or any third or external resource or dependency, because that's just going to kill performance. You're not going to be happy with the contract invariant stuff. So As you can see, in a matter of 7 or 8 minutes, we've taken a look at how we can utilize contracts to use the invariant techniques to validate the state of an object and do so in a few lines of code. We've taken a look at how the weaver rewrites the code and actually puts the calls at the end of all methods. So I hope you learned something. Until next time.